Hello everyone. Today we are going to solve a linear programming problem. It's a very simple problem of some manufacturing product. So the question says that a manufacturer would like to maximize the profit by producing standard bags and deluxe bags. So from this first line, we know that it's a maximizing problem, and we have to decide for the two variables, which are standard bag and deluxe bag. Okay, a profit of which $10 for standard bag and $9 for every deluxe. So here we can say that there are two decision variable. I am putting like X1 for standard bag and X2 for deluxe bag. You can write A or B, X or Y. You can use anything. And here further, it's as it's a maximizing problem. So our objective function would be 10x1 and 9x2. 10x1 as it's for standard bag and 9x2 it's for deluxe bag. We have to maximize this equation. Further in the question it says average standard bag will require 7 over 10 hours for cutting and dyeing, half for sewing, 1 hour for finishing, and 1 over 10 hour for inspection. So we can write our subject to constraint as 7 over 10 x1. For sewing, it is half x1. For finishing, it's 1 hour. And for inspection and packaging, it is 1 over 10 x1. Okay. It's a maximizing problem, so we can sum up. Now, further for the deluxe bag, it says that 1 hour for cutting and dyeing, 5.6 hour for sewing, 2 over 3 hour for finishing time, and 1 over 4 hour for inspection and packaging. So further we can write here x2 as 1 hour, 5 over 6 x2, and here 2 over 3 x2, and 1 over 4 x2. As it's a maximizing problem, so we are going to use less than and equals to symbol. Okay, we can just copy so we can paste further. Okay, so and in the end, the director has stated that the total time required for all these tasks are 630, 600, 708, and 135 respectively. We are going to write like we have to maximize the objective function within these hours. We cannot exceed them. So that's why we are going to write 600. Oh, sorry, it's 630 here. And then it's 708. And for inspection and packaging, it is 135. Okay. And yes, at last, we shouldn't be forgetting that are non-negative constraints, which are x1 and x2, and they can never be less than 0. Like it means that we cannot have a negative answer to that because it's a profit maximizing problem. So we can, our x1 and x2 can never be in a negative value or equals to 0. All right. So here it is. Now we will move forward to Excel and then later we will solve it through our studio. So here I have created very simple table to explain all over the solution. For the this table is for the objective function, this one is for all the constant, and this one here will be the solution at last. So our profit for objective function was 10 for standard pack and 9 for deluxe pack. For a constraint, we have first we are going to change this whole table to fractions because we have so many values in fractions. Okay, so it was already in fraction. We will do up to 2 digits. It's fine. All right. So 7/10, 1/2, 1, 1/10. These were for standard backs, and for deluxe backs we have 1, 5/6, 2/3, and 1/4. And then we will write our right hand side value, which were 630, 600, 708, and 135. So these two boxes will remain empty because we are going to find out what will be in it. So all right, and here we can write the total number, our total hours. So which will be like our, sorry, which will be the objective function. So I'm using the sum product formula here. Like we will be going to make two arrays because this one is x1 and this one is x2, and we have these 10 and 9 in our question. So we are going to find out the answer to that. All right. And similarly, we will be writing product, sum product using these two arrays and these two. And we are going to make these. Okay, I have logged these values because are subject to constraint. All four equations are having x1 and x2. So we can literally drag it down and it will come all zero here. Now we are done with creating equation on Excel. The next step will be going to data, opening Excel solver. This type of window will appear. We will set our objective to the objective function. This will going to be only one cell, this one, and our decision variables. For the subjective constraint, we will use the left hand side first. I'll, these the whole column are the equations that we created before, and here it will be this. Because we want to maximize the profit by decreasing the hours. So we will see that how much hours we can decrease from the given hours to achieve our total profit. All right, then select OK. As it is a linear programming problem, so we will select Simplex App LP here and then click Solve. As there is no error, it means that things go smoothly and we have achieved our goal. So here it states that only the cutting and finishing time takes the total time that was given, but we utilize the less time for sewing and less time for inspection. So it's good. And for that, we have the solution for standard bag that is 540 and deluxe 252. We can successfully create 540 standard bags and 252 deluxe bag with this amount of profit. So we have maximized the profit by reducing the hours. So now we will solve the same problem using RStudio. Yeah. After coming to our studio, the first thing we are going to do is to install a package called LP Solve API. I'm using this to perform my linear programming model. It's up to you. You can use any of the package, just making sure that it's completely installed. So yes, it is. And then we will start making a linear programming model. So I'm assigning it as a model. You can name your model anything you want. Here, LP stands for linear programming, and 0, comma 2 means like I have here is 0 row and 2 columns, which is x1 and x2. And now we will set the objective function. There's our profit value. Okay. And then let's start adding the constant. Let's read the model first, and then similarly how we did in Excel. Less than and equals to. You just simply copy it and then paste. Let's make changes. Put 10 and 1 over 4. Here it is 708, and here it is 135. All right then. Our constraints are set. Now it's up to us. We can name the row and our columns. First one is cutting. Second one is spring. Third one is finishing. And the last one is inspection. All right. Now the column. Here we can write standard bags or deluxe bags. Sorry, I forgot to mention the commas. Here we go. All right. Okay. And then we will set the dimensions of the model list row and comma col and all right. Now this one is LP control function to sense that it's a maximum problem, maximization problem. Okay, so here it is. Let's print our problem, print model. It will be something like this. You can see that our problem is changed to maximization. In this LP solve package, you always have to use this function of solve. You have to solve the model first, and it should come zero here. Basically, this zero just indicate us that our optimal solution can is it will be right, and it can match our the same solution what we get in Excel. So it means like zero is a good sign for this LP solve package. Now let's get our objective function answer and the variables. Get objective model. So it says 7668. Get dot variable model and this. You can verify the answers from the Excel as well. It's up to you. So now let's state our statement that number of standard bags to produce is, comma, let's round it off the variable model till 1. Okay, so it's 540 for standard bag, and similarly we can state the same statement for deluxe bag. And here we will be putting 2 instead of 1. So it's this. And then finally, our profit. The profit is dollar sign round get dot objective model till 0 decimal place. So yes, it's done. So here's how we do our linear programming function in R Studio.